All right, so negative x to the fourth plus 4x squared minus 2x minus 1. We want to identify all these characteristics for this function, domain and range. Well, domain is easy because it is always all real numbers. I encourage you to write the symbol and the interval notation just so you continue to get used to seeing both of those. Okay, all real numbers and negative infinity to positive infinity. Now, this one is an even degreed function, so I know that it's going to have a restricted range. So I'm going to go ahead and put this in my calculator. And I know it's going to be opening down, so I have this maximum right here. I need to find out what that value is. So second trace maximum is number 4. Left bound, I got to move my cursor to the left side of that peak, to the right side of the peak. You don't have to move it for the guess, you can just press enter. And there's my maximum. Remember, I'm talking about the y values when I'm talking about range. So my y values are, everything's below that, so it's y is less than or equal to 5.944. Anytime you have to round like that, I like to put 3 digits after the decimal, mostly just to benefit those of you that are going on the calculus because you have to use 3 digits after the decimal in calculus. Interval notation, remember bottom to top, so we start with negative infinity. Our limit to this is 5.944 with a bracket because it's an exact value. Now, when you do this on your paper, I suggest when you graph it on your calculator, go ahead and start adding these specific points to the graph on your paper, because when we get ready to do intervals of increasing and decreasing, guess what? I'm going to need that x coordinate right there. So I don't have the graph on my paper, so I'm just going to go over here and I'm going to jot down that my that I've got a max at negative 1.526. Just so that I have those numbers in that coordinate, because I'm going to need it here in a minute. I don't want to have to do this 10 different times to get a point that I've already found. All right, x and y intercepts. The y-intercept is easy, right? The y-intercept is the constant. I do want you to write it as a point though. Okay, 0, -1. The x is always 0. It's the y-intercept, so you have a value for the y. It's the constant on the end. You can see it on the graph. The easiest way is just to use the constant on the end. Okay, x-intercepts though, those are going to take a little bit more work because I cannot factor this expression to solve. So I'm going to have to second trace option number 2 is your 0. You should know how to do most of this. I'm just kind of running through a review here because it's probably been a little while. Left bound, right bound. Okay, there's one of my zeros or my x-intercepts. -2.17. I've got, what, 3 more? Or 2 more? -0.311. I can't tell whether that crosses twice or not, so I'm going to adjust my window so that I can see a little bit better. I'm going to change it from -5 to 5 on my x's and my y's. I am not a fan of zooming on your calculator. It's better to adjust the window because you can control it easier. It does actually cross twice. So I got 2 more that I got to find. One 0. Well, that's nice. That's a nice even one. And one more time. Make sure that your cursor is above the x-axis right there. Make sure you have a positive y value. And then I need a negative y value to get below on the other side. So 1.4810. Okay, so domain range, x and y intercepts, local maximums and minimums. I don't know why I wrote local, I just want all maximums and minimums. So we've already got one, we've got the absolute max. So absolute, you can abbreviate that ABS, max. I already know what that is, negative 1.526, 5.944. Okay, let's look at the graph. I have an absolute minimum, or excuse me, a relative minimum and a relative maximum that I need to find. So second calc, I'm closest to the maximum, so I'll go ahead and do that one. Left side of it, right side of it, relative max, 1.267.310. And then a relative minimum. And yes, I would like for you to identify whether they're relative or absolute. Okay, that's good practice as well. .259, negative 1.254. All right, so I've identified all those, which means my intervals of increasing and decreasing should be pretty easy at this point. But here's an advantage to you drawing it on your paper. You can put your little lines in there to help you out. But we start by increasing. So we are increasing from negative infinity until we get to our absolute maximum, negative 1.526. Remember, use those x coordinates. Then we decrease. So from the negative 1.526 until that minimum, 0.259. Then we increase again, 0.259 until we get to our max. What was that x coordinate? 1.267. And then we finish by decreasing, 1.267 all the way out to the right. This is what messes with people. We are decreasing, we are headed to negative infinity, but remember, we're using the x values. So that is supposed to be a positive infinity right there. Okay, that is supposed to be a positive infinity because we're using x's. All right, so that's all our increasing and decreasing. And then last but not least, let's talk about end behavior. You can do this from the very beginning. I encourage you to do this at the beginning so you can practice doing it without your calculator. As x approaches negative infinity, as x approaches positive infinity. Okay, so I know I've already looked at the graph. I know what it looks like, but let's think through the process. Even degree, so they're going the same direction. It's negative x to the 4th, so it's facing down, so they're both going to negative infinity. You, of course, have your calculator right now. You can confirm that by looking at the graph, but again, I would practice it before I graph it and look at it, okay? All right, any questions about anything that I did in the calculator? I know I went through that kind of fast, but I figure y'all have done all this before. I just wanted to refresh your memory on where stuff is and how to do it. Again, save yourself some time. When you find maximums and minimums, you're gonna have to use those coordinates again. So you might as well write them down on the graph because you need them for your increasing and decreasing and for your range as well. So you need those values.